Welcome back, everyone. Today we're looking at ancient Mesopotamia, but, not just as some dusty chapter in a history book. What if I told you it was actually the world's very first massive data infrastructure? In this explainer, we're going to bridge a 5,000-year gap to see exactly how the very first accountants managed incredibly complex economies and how modern computer scientists are resurrecting their shattered archives today. Let's get right into it.
So, let's start with just a mind-boggling number, 500,000. There are over 500,000 surviving cuneiform tablets scattered across global museums and private collections right now. And this spans roughly 3,350 years of history, literally from the dawn of writing all the way to the 1st century CE. You really have to think of this as a massive, shattered, ancient hard drive that's just sitting there, waiting to be decoded.
Okay, so let's look at the actual hardware of the ancient world. What you're seeing here is a clay tablet. This is the exact device used to manage those early, rapidly expanding urban centers like Uruk. And notice how chunky it is, right? It's definitely not a flat piece of paper. It's very much a three-dimensional artifact. But to understand how we even got here, we kind of need to look at how ancient human cognition evolved in the first place.
Let's trace this tech tree for a second. Before writing even existed, administrators counted things using physical 3D tokens, just these little geometric clay shapes representing specific goods. Then, they started sealing those tokens inside hollow clay spheres called boule. But eventually, someone had this brilliant cognitive leap. Why put the tokens inside when we can just press them right onto the outside of the clay? That mapped a 3D physical tally directly onto a 2D visual surface. And this idea caught on fast. It rapidly evolved into flat numerical tablets, and then finally into proto-cuneiform, which paired those numbers with pictographs.
And honestly, this brilliantly illustrates our core point today. We tend to romanticize the invention of writing, right? We think of it as this vehicle for poetry or epic myths. But as the scholar N. Veldhuis points out, archaic cuneiform was really the ancient equivalent of a corporate spreadsheet. It was designed entirely for complex administrative tracking. It wasn't poetry, it was data.
Which brings us to our first main section, big data in clay, and how they scaled the administrative state.
To handle the massive expansion of the state during periods like the Earth-3 Renaissance, scribes started using these huge clay canvases. Just look at the sheer scale of the data we're talking about here. The Earth-3 tablet, MVN 15390, that has over 1,600 lines of writing on it. Or consider the famous Record of Temple Workers from the Uma province. That one features a 24-column layout just to register the names, wages, and specific labor duties of nearly 20,000 workers. When you treat this as a data infrastructure, it really reveals just how sophisticated these ancient societies actually were. They literally scaled the physical size of the clay to match the data requirements of their state.
Moving on to Section 2, the Digital Cuneiform Revival, where we look at resurrecting all this data.
So you might be wondering, how exactly do modern scholars archive 500,000 3D clay spreadsheets? Well, they use relational databases. Modern projects like the Cuneiform Digital Library Initiative or the Ebla Digital Archives, they don't just type out the text into a document. Instead, they use computational systems that actually mimic the ancient scribes' taxonomic hierarchies. So, by nesting individual sign occurrences within specific vertical columns and horizontal cases in the database, they're able to preserve the original spatial architecture of the document. Basically, they are turning 5,000-year-old clay logic into machine-actionable digital code.
All right, Section 3, 3D scanning the past, and why we have to move beyond flat paper.
For over a century, scholars dealing with cuneiform had a major problem: translating a highly complex 3D object onto a 2D surface. For a long time, they just relied on flat hand copies, like the drawing you see on the right. But as you can clearly tell from the real tablet on the left, cuneiform wedges vary in depth, and sometimes the ancient scribes literally ran out of room, so the text just wraps right around the curved edges of the tablet. Flat paper simply cannot capture that spatial reality.
To fix this, researchers today use a highly structured white light fringe projection workflow. Basically, the tablet is placed on an automated turntable. It requires a minimum of 14 separate rotational scans to capture the obverse, reverse, and all the edges, which takes about 20 minutes per tablet. After that, post-processing cleans up the digital noise to generate a unified, high-density polygon mesh made of literally millions of coordinate points.
And the results? They are absolutely breathtaking.
By manipulating virtual light, shadows, and depth coordinates with specialized 3D filters, researchers can extract details that are completely invisible to the naked eye. We're talking about extremely faint undertext cylinder seal impressions. And incredibly, this tech can even isolate the micrometric friction ridges, yeah, the actual fingerprints, left in the wet clay by the ancient scribes thousands of years ago. We are literally touching the past here.
Next up is Section 4, Reconstructing Shattered Archives, focusing on the VCTR project.
Now, what happens when these ancient hard drives aren't just hard to read, but they're hopelessly shattered, with their fragments scattered across museums all over the globe? Well, enter the Virtual Cuneiform Tablet Reconstruction, or VCTR project. They recognize that trying to physically piece together 500,000 broken fragments spread across the Earth is just impossible. Take the Anna Archive from Uruk, for example. That's 5,400 fragments, half of them sitting in Baghdad and the other half in Germany. So VCTR steps in to solve this massive global jigsaw puzzle using those virtual 3D meshes we just talked about.
Here's the catch, though. Standard 3D reconstruction algorithms usually assume a perfect interlocking fit. But real clay erodes along its break lines, so a standard algorithm just fails completely. To get around this, the VCTR team created a really ingenious, novel automated algorithm. It calculates the 3D geometry of those degraded boundary curves and surface orientations, and it finds the absolute optimal spatial rotation to snap those eroded fragments back together digitally. And guess what? It actually works. Using this system, they successfully achieved an automated long-distance virtual join of a piece of the old Babylonian Atrahasis epic. The physical fragments are still sitting in museum cases in London and Geneva, literally separated by 1,000 kilometers. But in the virtual space, they've been reunited as one complete tablet for the first time in millennia. How cool is that?
That brings us to Section 5, AI and Cyber Scholarship, the next frontier in data retrieval.
So now that we have this massive, reunited, digitized 3D database, how do we actually search it? Historically, searching digital archives relied on keyword searching, which, frankly, is deeply flawed for historical research. Old typefaces bleed, OCR gets mangled, and language constantly evolves. If you just search the keyword unemployment, you completely miss articles discussing idle laborers or the surplus population. But semantic querying through AI changes the game entirely. It actually understands the underlying concept you're looking for, and it retrieves the semantic meaning across millions of data points, bypassing the trap of exact keyword matches altogether.
We're basically entering an era where retrieval-augmented generation, or RAG systems, act as brilliant polyglot research assistants. You can ask an AI an open-ended, complex question about, say, administrative labor across thousands of texts, and in seconds, it navigates oceans of ancient print to bring up overlooked leads. But, and this is absolutely crucial, it doesn't replace the historian. Instead, it empowers them to perform deep, contextual, close readings on the exact right fragments without having to spend a lifetime searching for them.
Which leaves us with a truly provocative thought to end this explainer on. We're currently pouring immense resources into uploading the ancient information age into our modern digital cloud. And we're constantly marveling at how these 5,000-year-old clay spreadsheets survived millennia buried in the dirt. But look at our own servers, our degrading hard drives, our constantly changing file formats. Will our own digital archives be readable in 5,000 years? Or, ironically, was baked clay actually the ultimate, most resilient storage medium humanity ever created? Definitely something to think about. Thanks for joining me on this deep dive into the data of the ancients. Keep learning, keep questioning, and I'll catch you in the next explainer.